Hey guys, so I just wanted to go over a couple questions from worksheet 6 to help prepare you for tomorrow's quiz. So I'm starting with, like I said, worksheet 6. We'll start with this first part where we're looking at side lengths to first determine can they create a triangle, and if they can, then classify it. So the first thing you have to check is if the three sides can physically create a triangle. And the way you do that is you have to add the smaller two sides, and their sum should be greater than the third. And if that's true, then yes, it can physically form a triangle. So then you classify them. Then you do 10 squared plus 24 squared and determine how that relationship compares to 26 squared. So you find this sum and then you compare it to this sum. Now I don't need to actually do that because 10, 24, 26 is a 5, 12, 13 right triangle that's being multiplied by 2. So since this is a Pythagorean triple, I already know that this is going to be a right triangle. I don't actually have to calculate it because it's a multiple of a right triangle. I know it's going to be another right triangle. If you didn't see that, then of course you could calculate the sum and see that it does in fact equal the same as 26 squared. Okay, in part C, I wanted to do this one with you guys because to remind you that to always make sure that the longest side is your C. So in this one, it is written in order, but not all of them, they won't always be written in increasing order where the last number is the biggest. So just be careful as you're looking through to make sure that they are in fact the biggest. So 13 and 19 are the two smaller sides. If I add them together, is it going to be greater than 22? It is. So now I can compare 13 squared plus 19 squared, compare that to 22 squared. So this ends up being 530. 22 squared is 484. So 530 is greater than. So this greater than tells me that this triangle is going to be an acute triangle. Okay, so don't forget the 2 steps for these portions. First, make sure the sides can physically create a triangle and then classify. Okay, the first one I want to do with the actual triangles is starting with number 4. So here we have 2 separate triangles. You always want to start with the triangle that has the most information. So in this one, that's this triangle here. We know 2 out of the 3 sides. If you know 2 out of the 3 sides, you can use the Pythagorean theorem to solve. But I know that if the legs are 3 and 4, I know that that's a triple. It's a 3, 4, 5 right triangle. I don't actually have to do the Pythagorean theorem since I know my triples. So then, once I get the first one, then I can move to the second triangle and look at this green one. And again, look to see, sorry, I don't know why that went crooked, try to solve that missing side. So here, I'm just going to redraw it this way. So I have one of the legs is 5 and the hypotenuse is 13. Again, I could do Pythagorean theorem, do 5 squared plus x squared equals 13 squared, but I know my triples. I have them memorized. This is a 5, 12, 13 right triangle. So I don't even need to do the whole Pythagorean theorem since I know my triples. So make sure you have your triples memorized. Okay? Next one, number 9. So we always want to look for the triples. You've seen in a couple examples I've already done, triples has been a huge help. So we look at the sides that are given to us and we look for either one, are they part of a triple, or we look for a GCF to see if it's a multiple. 20 and 21 don't have a GCF and they aren't part of a triple. So with this one, we do actually just have to do the Pythagorean theorem. 20 squared plus 21 squared equals x squared. This is our hypotenuse. So we can just evaluate. 20 squared plus 21 squared equals x squared. So this side becomes 841. Equals x squared. So now I can take the square root of both sides. X equals 841 happens to be a perfect square. So x is 29. If it wasn't a perfect square, you would have to reduce the radical. Make sure you reduce the radical correctly. There should be no decimals in your final answer, only reduced radicals. Okay. Okay, let's take a look at number 11 here. So we have a right triangle here. This time there's only one side length given to us. Like in number 9, we had 2 side lengths, so we could do the Pythagorean theorem. In number 11, we only know one of the side lengths, so we can't use Pythagorean theorem. We have to use a different method. Since they tell us that this is 60 degrees, and this is 90, we know this is 30. 30, 60, 90, all three of these angles add to 180. So because it's a 30, 60, 90, we can use the pattern. The side opposite the 30 is A. The side opposite the 30 is A. The side opposite the 60 is A root 3. So in our case, this is going to be 15. And then our hypotenuse is 2a. So we take what's given to us and we solve that equation. So I'm going to take a root 3 that equals to 15, and I'm going to solve for a. So I'm going to divide both sides by that radical 3 to get a isolated, to get a by itself. We had to get rid of this root 3 to get a by itself. So I divided both sides by root 3. Now, in order to finish, I have to rationalize. We can't leave our answer with that root 3 in the denominator. So I'm going to multiply by root 3 over itself and get 15 root 3 over 3. Now 15 divided by 3 simplifies to 5. This is what a equals, right? A equals 5 root 3. So wherever I see a, I can put 5 root 3. So a is 5 root 3. So that means the side opposite the 30 is 5 root 3. We already know that the side opposite the 60 is 15. So now we just have to worry about f, which is our hypotenuse here. So I'm going to take a and the 5 root 3 and plug it in for a, 5 root 3, right? This is what a equals. So I can multiply across. 2 times 5 is 10, 10 root 3. So our f value is 10 root 3. Okay, make sure you feel comfortable with radicals. Remember, we spent 2 days on it, so if you're struggling with the rationalizing, you can look back at worksheet 2, and that should help. Okay, next one, I want to look at these 3 word problems. So let's jump down to 16. Given a right triangle with side lengths of 10 and 24, find the length of the hypotenuse. So again, if you know 2 out of the 3 sides, can you do Pythagorean theorem? Remember, the legs are the sides that form the right angle, and then we're looking for the hypotenuse. So you could do the Pythagorean theorem since you know 2 out of the 3 sides, but let me remind you, always look for that GCF. The GCF of 10 and 24 is 2. 2 times 5, 2 times 12. Do we have a triple with 5 and 12 in it? Yeah, this is a 5, 12, 13 right triangle that we're multiplying by 2. So since we have the 5 and the 12, we're going to take the 13 and multiply that by 2. So we now know that the hypotenuse is 26. Again, if you know your triples, it saves you a ton of work. If you don't know your triples, it's fine for now. You can always use the Pythagorean theorem, but again, let me encourage you to memorize those. Number 17, this one tells us we have a 45, 45, 90. Notice I'm never putting in angles, like if we look back at number 16, I'm never just saying, oh, I'm going to make this a 60 degree. Oh, I'm going to make this a 45. We can't just make angle measures whatever we want them to be. We have to be told, like this one, that they're 45, 45, 90. And remember, 45, 45, 90 are isosceles right triangles. So that means the legs of the triangle are congruent. So we can use the pattern A, the congruent legs, and then the hypotenuse is A root 2. So we were told the hypotenuse is 40. So what we have to do is solve this equation. A root 2 equals 40. We have to divide both sides by the square root of 2 to get A by itself. And we're good, except for that root 2 in the denominator, so we rationalize and multiply across. 40 root 2 over 2. 40 divided by 2 can simplify to 20 root 2. This is what A equals. So wherever I see A, I can plug in that 20 root 2. Okay, again, this is all algebra work here, all radical work. So if this is the part that's confusing you, you need to ask me or ask your teacher about radicals. So we're almost done, except this problem had asked for the perimeter of the triangle. So the perimeter wants the sum, is asking for the sum of the 3 sides. So the 3 sides are 20 root 2 plus 20 root 2 plus 40. Okay, so for the perimeter, we have to add these together. These root 2's, how many root 2's do we have? 20 plus 20 is 40, plus an additional 40. These are not like terms because this one doesn't have a root 2, so we're just going to leave it separate here, and this will be our final answer. Okay, last one. Draw an equilateral triangle. So I drew and filled in my equilateral triangle with everything that I know about equilateral triangles. We already know equilateral triangles have 3 congruent sides, and we know that in an equilateral triangle, all the angles are 60. I didn't guess. I didn't just say like, oh, just because I want to, I'm gonna make the angle 60. I know that in an equilateral triangle, angles are 60. They want, in this equilateral triangle, the measure of the altitude. So the altitude is the segment that goes from the vertex perpendicular to the base. We've already chatted about this, but the altitude bisects this top angle into 2 30-degree angles. It also bisects the base. So if this whole segment is 8, each of these is going to be 4. Okay? At this point, you have 2 options. If we look at this triangle, the altitude, I'll call that x. If I were to redraw this triangle here, we know that this is x, this is 4, this is 8. Could you do the Pythagorean theorem to solve? You sure can. The other option is looking at that green triangle. I can draw the green triangle again, fill in all the side lengths, but don't forget about this angle 60, this angle is 30. So doesn't this follow the 30, 60, 90 pattern? It sure does. A root 3, 2a. In this case, the side opposite the 30 is 4. So if a is 4, we're going to have 4 root 3 and 8. So we can say that x is 4 root 3 since it is opposite the 60-degree angle. If you would have stuck with it up here, you would have gotten the same thing. A is 4 root 3, just a different method of going about it. Okay? I know I went through these fast, but you can always rewind and go back and listen to it again, pause it, whatever you need to do. But these are some really good questions for you to take a look at and practice to help prepare you for the quiz tomorrow. Remember, email me if you have any questions, and have a great night.